Very good morning, students. Today we will be discussing about portfolio analysis. So I'll be writing a problem relating to portfolio analysis, and then we will start solution. So a portfolio analysis consists of 40% security of X and 60% of security Y. It has the following probability distribution of returns. Calculate portfolio return and risk. Now, the problem is divided into certain columns. So, here what I do, I create columns here. One is state, next column is probability, third column is return of X in percentage, then return of Y in percentage, okay, and we will be taking down what are the different states. One is boom, which has a probability of 0.1, and returns of X are 14, and return of Y is 20. Okay. Then after boom we have recession, and here the probability is 0.2, and the returns are -5 and -2. Okay. And next we have normal. In normal state it is 0.4, and the returns are 10% and 9%. Another state is recovery. Under recovery state it is 0.1 and 9% of X and 14% of Y. And last stage is slow growth. In this we have 0.2 as a probability and 12% of X, and then we have 18% of Y. Okay. Now we have to calculate the probability return and the probability risk. So we write solution. Under this, calculation of probability portfolio return. Okay. So here we take probability as first column, and return of X as Rx, and return of X multiplied by probability X is Rxpx, and then return of Y Ry, then return of Y with the probability Y. Now probabilities are taken as 0.1, okay, and next we have 0.2, next we have 0.4, next 0.1 and 0.2. These are different probability situations. Now return of x is already given to us, it is 14%, and next we have minus 5%, next we have 10%, next 9% and 12%. Now we multiply the probability with the return of x. 0.1 into 14 is 1.4. Next, 0.2 into minus 5, minus 1, it is minus 1. So, next is 0.4 into 10, 4. Next, 0.1 into 9, 0.9. Next, 0.2 into 12, 2.4. When we take the total of this, we will get 1.4, 5.4. The total will be 7.7. Okay, and the next return of y is given as 20% in one state, and in another state it is minus 2. Next we have 9, next 14%, and lastly we have 18%. So return of y is also multiplied with the probability. 0.1 into 20 is 2. 0.2 into minus 2 is minus 0.4. Next, 0.4 into 9, 3.6. Okay. Next, 0.1 into 14, 1.4. Next we have 0.2 into 18, 3.6. So when we take the total of this, we will get, after addition, 10.2. So this is the total. So what we have to do is, as the problem says, portfolio consists of 40% of x and 60% of y combination. We can calculate the portfolio return with the help of one simple formula. Portfolio return is equal to whatever is the 40% security of x is given, that we will take as weight of x multiplied by whatever the return that we get, expected return with the probability, we write Rx P, because we multiplied with the probability. Then this is to be added with the second weight, 60% of security y. So weight of y multiplied by return of y multiplied with p. We close the bracket. Now we calculate the portfolio return as 0.4 multiplied by 7.7. Return of x is taken as 7.7 plus weight of y is 0.6 multiplied by 10.2. So when we multiply this, 0.4 into 7.7, we get 3.08. When we add this with 0.6 into 10.2, it will be 6.12. So the total comes to 9.2%. This is our return. Okay. Similarly, we can calculate the risk also. So for calculating the risk, we simply use one formula. Okay. So I'll be continuing this with the return risk of portfolio. So I write determination of portfolio risk. So here what we have to do is we have to calculate the deviations and then calculate the standard deviation. After that we calculate the covariance, coefficient of correlation between security X and security Y, and then we apply one simple formula which is called as weight of X square multiplied by standard deviation of X square plus weight of Y square multiplied by standard deviation of Y square plus 2xy, standard deviation of X and standard deviation of Y, which is again multiplied with the respective weights. So we can calculate the portfolio risk. So here I try to show you individually we calculate the standard deviation, that is standard deviation of X and the standard deviation of Y. Okay, and then we calculate the covariance. Now let us proceed calculating the standard deviation of X so that we can calculate individually. So I try to take the same columns here and then copy it here. Okay, so only two columns I will copy. Okay, lateral part I will be removing it. Okay, I think you are able to see whatever the calculations that we have made here. Okay, so I have taken the return of X and then we will take the total of these returns. Okay, so when we take the total of these returns, it will be 14 minus 5 plus 10 plus 9 plus 12 would come to 40. Okay, now what we do is we take the deviations. So I call it as D here, and then we proceed. Okay, and if we have to calculate deviation, we have to calculate the average of the returns. So average returns of X is equal to sum of X returns divided by the number of items. Now we calculate, that is equal to 40 divided by 5. We get 8. Now what we do is we take the deviations. 14 minus 8 is 6. Next, minus 5 of minus 8 is minus 13. Then minus 10 minus 8, 2. Then 14 minus